Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my DIY milling machine, otherwise known as the Green Machine Mill. I believe we are on video number 11 in this series. Let's go ahead and look at this. Video 11, I'm pretty sure. 9, 10, yeah, video 11. So, basically, off screen, I finally whittled down to the ones that I'm going to go with. So, basically, what I decided to do was I decided to go with the 2005 and the 20CA or 20HA, basically the same deal. So what that means now is that it's very balanced. So 20 millimeters is approximately 3/4 of an inch, and it's a little bit bigger than a standard. For example, I have a Cetus 3D printer here with a Highwind rail on it. It's a 15 millimeter rail. So let's go ahead and look at 15. So it's about 0.59. I think it's even smaller than that. So it's probably the next size down. It's a little bit smaller, but then again, my calipers, these ones are dead. They're out of battery, so they don't actually turn on. But I'm thinking that it's pretty close to that. I think it's a little bit under. It's about a 0.4. So a 3/4 inch rail, I think we're not going to have any issues with that. So now if we look here, we'll see that it is, if we go into here, we'll see that it is incredibly balanced. So here we have almost 3/4 inch. So if we take a little bit of slack out, well, before we do that, let's go ahead and I wanted to check, and I wanted to do that here. Let's look at the BT40 power head. Let's look at these dimensions one more time. To go from this hole to this hole, we need 105 millimeters. That's 4.133 from tip to tip, and then to edge. So what about the whole machine itself? Where'd it go? Whole machine. The whole machine itself is 135. So 135, 5.315. Ooh, you're gonna see past this a little bit. You're gonna see on the outside of the power head. That's not that big of an issue. Maybe for bracket stability and stuff, but you're gonna see a little bit past that power head because we are a little bit over that. So here it's asking for 135 this way. So it's going to be a little bit bigger than the power head, which is how it is on the Tormach. Tormach's also bigger than the spindle itself. So, I mean, that's pretty normal. So, but that way, so we're using a 2005 screw. And I believe the 5 again is 5 millimeter per turn. So we don't want the 10 because we want a smaller per turn, higher accuracy. So, and then we're doing the HGH 20HA, which are the L65.2, and this guy 65.2 divided, basically one of those. So we're looking at, and so from here to here, it's 130. So from here to here is probably I'm going to say this is probably, so let's say a fourth. 1, 2, 3, 4. Yeah, let's divide this in 4. So it's about 40. So I'm going to say 40 here. 40 here, 40 here. So that's 80. Oh, L1. We want L. 92.2. So yeah, I think it's going to be extremely close. I think actually we could probably use the HGH20CA. I mean, the other one would be really good. They would basically utilize the entire bottom of the machine. We could probably do that as well. It's going to utilize the most of the carriage. Will it fit without... so that's 180. I think it'll fit. It'll fit just barely underneath there. So that's good. I like that. Okay, so we have that. So let's go ahead and go to Highwind again, and let's go ahead and grab these rails, and let's write down here that we're going to use the HGH20 HA 20CR, and we're going to use the 2005. And so, yeah, so now everything's incredibly balanced. Obviously here it's extremely thick. And another thing is when we save this and we go to manufacturing, if we look here, this is not going to be exact because I made some changes, but we see that we have almost 65, almost 66% retention of material. So now if we go back to model and we browse the properties, and we look at 2265 divided by 16, we have almost 150 pounds of material. So let's look at the Highwind. And then we'll drop the let's do a new folder. I'm going to call this HGH20HA. So let's go Highwind Corporation, products, linear guideways, and HG series. And then we're going to look at HG rail. So now again we're going to do the difference between the two. So we want to do HG20 mounting from top, rail length. We want to go basically all the way from the top to the bottom. That's 34 inches. 34 inches is 863.6. 863.6. It doesn't have to actually go all the way down the bottom, so we could change it later and get some different ones, but precision code, just standard. C, standard rail. Everything's good. Okay, let's go ahead and grab 3D. Step file. Submit. Save. Downloads. Or I could go here. Quick access. Upload. HGH. And while this is uploading, get the next one. So now we're going to go back again, block. Okay, HGH20, square type, standard load, mounting from top, standard block, light preload, regular. none, view results. 3D. Let's go ahead and upload. Perfect. Download. Save. Ooh. So as you see there, I made a mistake. Oops. So I think the super heavy load is the HGH. I mean the HA. Total length 92 millimeters. Is that right? Yep. So yeah, that's it. That's the heavy load. And there it is. I made a mistake here though. Flange type. 20 square super heavy load mounting from top, precision code. There we go. HGH20HA. Oops. Upload. Okay, so now what we're going to do, let's go ahead and go back to the original. Let's HGH20 CHA and CR assembly. Okay, so let's go ahead and drop in this guy. Okay, that's good. Drop in this guy. And again, two blocks per. Oops. Okay, let's go ahead and drop another one. Move it all the way back here. Sure. That's freaking weird. It might just be at the just the base start of it. That's okay. There we go. And there is our rail. Okay, so let's go ahead and save that. Okay, so let's do a new upload, and this is called, oops, new upload, not new upload. This is going to be called, I call this the custom style layout. We're just going to use our main custom Z gantry right here. Okay. And then it's going to use two of our linear rails, HGH assemblies. Just go ahead and joint it. What? That's strange. Oh. Beautiful. Turn off the joint. Let's drop another one in there. Joint it. Tiger. Don't do it. And there it is. But obviously these are like nearly touching. Actually, they are touching. So we'll probably drop these down to 3/4 by 3/4. But you could see here we are definitely doing what we need to do. So I wonder if Highwind has the 2005. I saw that they had the ball screw. They do. Okay, so they do have ball screws. I think this is basically the size. There's just a nut. Oh, what the heck? It's weird. Okay, so let's go ahead and show you guys this stuff here. It's a weird freaking tube on top. So I think it's this. I'm pretty sure it's just this. Okay, but where is the basically. Okay. Okay, so let's go ahead and let's download that. Okay, now where are the where's the model of the actual ball screw? Hmm. Yeah, that's definitely not it. Well, I guess they don't have any CAD for the... Oh. Yeah, so basically that's it. So it's just a standard. Well, looks like I'm gonna have to look elsewhere for that. So now how are we looking? Properties. Two four 248. Okay, so we had another 200. Properties. That's about 156 pounds. using steel. Okay, and then basically what we're going to do is, before we end, so basically what I'm thinking is that we could probably do the same exact thing again and use the same exact plate, pretty much. Except for it would be a different length. Be a different length. What's my length again? 29-inch depth. Okay, so this is what we'll do. Let's go ahead and duplicate this. Let's go ahead and delete that. Let's go ahead and rename this. This is Y. Okay, so now let's make this. So it has to be 28 inches. And then what we're going to do is we're going to go on top here and we're going to make some of it solid. Okay, so this is basically what we're going to do. We're going to go here, open up this. And then basically from here back is going to be solid. Technically we'll probably do here back, it'll probably be solid 1.5 inches. Okay, so let's do this. Just like that. Obviously there's going to be issues with roundness here on the corners. Probably come in with tiny little end mill and work in that. So but right now we're not going to worry about that. I might even do a little cutout there in the corner just so I could get that opening. Okay, a little Mickey Mouse here. Alright, so now basically what that does is now we could use, go back here, products, linear guideways, HGH series, and then we're going to do HG series rail. And look at this distance from here to here is 26.50. 26.50. 26.50 is 673.1. 673.1. Download. Download. Save file. Upload. Let's call this one HGH20HA and CR short. Whoops. Now, whether or not, let's see if we're going to use HA. I think HA is going to be a little too big, but we will see. Okay, so let's just finish this here. We are over time by a little bit. Okay, let's turn off joints. Okay, let's drop custom Y gantry down. Boom. I know, Tiger. Just wait for everybody to go to sleep. You can walk around. Okay, so there's rigid. Let's go to linear rails, HGH20CA, HGH assembly short. And then let's go down. And then HGH assembly short. This is looking really good, guys. Really, really good. Wait. All right. This is pretty much it for today, but it's looking really good. Obviously, these things need to be opened up just a little bit. Just a little bit of room. But now our general assembly is 4,061 divided by 16. About almost 300 pounds. So add another this, add another that. It's probably gonna be, we're shooting for about 1,000 pounds, maybe 900 pounds, something like that. But you can see that these are big carriages. I think we're gonna have a lot of fun with this stuff here. And everything here, now these rails are cheaper. I think I'm going to get this for a pretty good deal, this steel itself here, because it was outside, so it's rusty and stuff. It needs to be cleaned up. And it's going to be machined anyways, but how I'm going to attach this stuff is going to be the interesting part. Right, it needs to be held first to the point where it is square, and then need to go in and like weld here or whatever. So probably have some sort of bracket, and then kind of mic everything out so it's square, and then come in, weld here, grind, weld there, grind, weld here, grind. So everything is nice and square with each other. Alright, so that is looking really, really good. I am very happy with this as it is so far. And also I need to add some play here too. But everything looks really good. Alright, so we are looking very good progress here. Thank you guys so much. This video has gone on a little long, but this is episode 11, and I'll see you guys in the next one. Thanks for watching. Take it easy. Peace.